Hello children, in this video we'll be solving miscellaneous exercise of your chapter 1, that is sets. It has 16 sums, so without wasting time, let's solve these sums. First question is, decide among the following sets which sets are subsets of one and another. A is x belongs to real, and x satisfies this quadratic equation. B, C, D are given. Now let's find first the elements of A. So x square minus 8x plus 12 is equal to 0. This we can write as minus 6x minus 2x, so that their multiplication is 12. Take an x common. X minus 6 taken common. So we got x equal to 2 and 6. So we have A is equal to 2, 6. B is already in roster form. 2, 4, 6. C is there. 2, 4, 6, 8 and so on. And D we have only single element 6. Now from here we can see A is subset of B. So we can write A subset of B. A is subset of C also. So we can write A subset of C also. A is not subset of D. Okay, so we won't write this. Then let's check B. B is subset of A? No. B subset of C? Yes. So we can write B is subset of C. B subset of D? No. Now check with C. C, no. To the B, no. To the D, no. So C is not subset of any of these given sets. Now let's check D. Is D subset of A? Yes. Is D subset of B? Yes. Is D subset of C? Yes. So we have written about these sets which are subsets of other set. That's your answer. Second is, in each of the following determine whether the statement is true or false. If it is true, prove it. But if it is false, give an example. Okay. In first part, if x belongs to A and A belongs to B, then x belongs to B. So we have to tell whether it's true or false. So let's assume this x belongs to A. Let A is equal to 1, 2. A belongs to B. So let us take B is equal to 1, 2 and any other element 3. Now let's check x belongs to B or not. Okay, suppose x is 1. 1 belongs to A? Yes. And A belongs to B? Yes. But here 1 does not belong to B. We can write here, but x is equal to 1 that does not belongs to B. So this is false. Next we have this is the second part. If A is subset of B and B belongs to C, then A belongs to C. So we have to check whether it's true or false. If it is true, we have to prove it. If it is false, we have to give an example. So let us take A is equal to, suppose 1, 2. Because A is subset of B, so B we take as 1, 2, 3. And B belongs to C, so C we can take as one element as B and one more element we can take. Now let us check whether A belongs to C. No. So we can write here that A is subset of B B belongs to C, but A does not belongs to C. So it is also false. Third part is, if A is subset of B and B is subset of C, then A is subset of C. Yes, this is true. Why? Because suppose any element is X and that belongs to A, and A is subset of B, then it will definitely belong to B. We write here because A is subset of B. And this also we are given B is subset of C. So if X belongs to B, then X will definitely belong to C, because B is subset of C. So here we have X belongs to A and here X belongs to C, then definitely A will be subset of C. So it is true. If A is not subset of B and B is not subset of C, then A is not subset of C. This is not true. So through example we explain. Let A is equal to 1, 2. A is not subset of B, so we can take B as suppose some 3, 4. B is not subset of C, so C we can take like 1, 2, 3. Okay, we take 4 here in B, which is not in C. You can see A is not subset of B, B is not subset of C, but A is subset of C. So this is false. Fifth is X belongs to A and X does not is not subset of B, then X belongs to B. It's not true. So let's explain it with the help of an example. Let A is 1, 2. A is not subset of B, so B is suppose 1, 4. Okay, so here you can see X belongs to A, so let 2 is there which belongs to A, and A is not subset of B, but 2 does not belongs to B, so it is false. If A is subset of B and X does not belong to B, then X does not belong to A. Yes, it is true. Suppose A is 1, 2, B is 1, 2, 3, because A is subset of B. So you can see any X which is not in B cannot be there in A. Or you can understand it using Venn diagram. Suppose this is B and this is your A. So if any element is not there in B, it cannot be there in A. So this is true. Okay, one more method is there. Suppose X belongs to A. Okay, let X belongs to A. This is assumption. So if X belongs to A, as A belongs to A subset of B, that means X will definitely be in B. I mention over here because A is subset of B. But we are given X does not belongs to B. So therefore our supposition is wrong. Therefore X does not belongs to A. So we can solve one question with many methods. Third question is, let A, B and C be sets such that A union B is equal to A union C and A intersection B is equal to A intersection C. Show that B is equal to C. We are given A union B is equal to A union C. Both sets are equal, so intersecting with the same set will also give the same result. B intersection A union B, definitely it will be B, because we are intersecting something with the adding something to B, that is A union B will be more than B, and taking intersection with B will be B. Using distributive law, we get B intersection A union B intersection C. Let's mark this as equation number 1. As we have taken intersection of B on both sides, let us take intersection with C on both sides. So C intersection A union B is equal to C intersection A union C. Using distributive law, C intersection A union C intersection B is equal to C intersection A union C, again is C, as we have done here. C intersection A is equal to A intersection B. So we are using what is given. So let's mark this as equation number 2. So from 1 and 2, because right hand side of first is equal to left hand side of second, so left hand side of first will be equal to right hand side of second. So that is our answer. Fourth question is, show that the following 4 conditions are equivalent. First is A is subset of B. Second is A minus B is phi. Third is A union B is equal to B. Fourth is A intersection B is equal to A. So what we are going to do in this sum will equate or show that first is equivalent to second, then first is equivalent to third, and first is equivalent to fourth. So by this we can say that all 4 are equivalent to each other. So let's solve by showing that first and second are equivalent. So first we assume let A is subset of B. Now we have to prove A minus B is equal to phi. So let us assume A minus B is not equal to phi. That means there exists some x which belongs to A and x does not belongs to B. But this is not possible. Why? Because we are given A is subset of B. So if A is subset of B, if elements are there in A, they will be in B also. So therefore, our supposition is wrong. That means A minus B is equal to phi. So by this we have proved 1 implies 2. Now let us assume second, that is A minus B is equal to phi, and will prove that A is subset of B. So let us assume that x belongs to A. So there are 2 cases, either x belongs to B or not. Let us write this. Case 1, when x belongs to B. So here x belongs to A and x belongs to B, that means A is subset of B. So this is proved. But case 2, if x is not there in B, x belongs to A and x does not belongs to B, this is not true, because if it is true, that means A minus B is not equal to 5. So this we have to reject. Okay, so A is subset of B. So with this we proved that second is equivalent to 1. So from these two, that is 1 and 2, I write from 1 and 2, we prove 1 and 2 are equivalent. Now we try to prove 1 is equivalent to 3. So here we assume A is subset of B and will prove A union B is equal to B. To prove this, we know that B is subset of A union B, because this is more than B. We mark this equation as something, suppose A, and at some point we'll prove A union B is subset of B, so that combining these two will get A union B is equal to B. Let x belongs to A union B. So x belongs to A or x belongs to B. If x belongs to A, then x will definitely belongs to B, because A is subset of B, we have assumed. And if x belongs to B, then also we are starting with A union B, and x belongs to B, that means A union B is subset of B. Here also A belongs to A union B and x belongs to B, so A union B is subset of B. So from both of these we got the result A union B is subset of B. Let us mark these equations as B. So from equations A and B, we get A union B is equal to B. So it gives us 1 implies 3. Now to prove 3 implies 1. So for that, let us assume A union B is equal to B, and we are to prove A subset of B. To prove this, let us take x belongs to A. If x is there in A, definitely it will be there in A union B. A union B we are given is equal to B. So x belongs to B. I mention over here. So here x belongs to A and here we get x belongs to B. That means A is subset of B. So here what we proved, 3 implies 1. So I mark this as equation number 3 and this as 4. So from 3 and 4 we proved 1 is equivalent to 3. I write here proved also. Here also I write proved. And we started proving here 1 equivalent to 2. Next we need to prove 1 is equivalent to 4. That is, we'll assume A is subset of B and we'll prove A intersection B is equal to A, which we can prove by, we know that A intersection B is subset of A. We mark this as equation number C, suppose, and somewhere we prove that A is subset of A intersection B. To prove that, let us take X belongs to A, X belongs to B also, because A is subset of B. So it means X belongs to A intersection B also, because X belongs to A also, B also, so definitely it will belong to A intersection B. So here we have X belongs to A and here X belongs to A intersection B. So from these two we can write A is subset of A intersection B. So let's mark this as equation number D. So from C and D, we can write A intersection B is equal to A. Now this we have proved 1 is implies 4. This I mark as equation number, suppose 5. Now we prove that 4 implies 1, that is, we'll assume that A intersection B is equal to A, and we'll prove A is subset of B. So X belongs to A, X belongs to A intersection B, because we are given, we have assumed this, that A is equal to A intersection B. I mentioned here A intersection B is equal to A. So it means X belongs to A and X belongs to B. We started here X belongs to A and here we have X belongs to B. Therefore A is subset of B. So by this we proved 4 implies 1. Let us mark this equation number 6. So from equations 5 and 6 we proved that 1 is equivalent to 4. So that's your result. Fifth question is, show that if A is subset of B, then C minus B is subset of C minus A. So let X belongs to C minus B. This we can write as X belongs to C and X does not belongs to B, which in turn we can write X belongs to C and X does not belong to A, because we are given A is subset of B. So if it is not in B, how it can be in A? This we can write as X belongs to C minus A. So here in the first step we have X belongs to C minus B and also X belongs to C minus A. So from these two equations we can write C minus B is subset of C minus A. Assume that PA is equal to PB, show that A is equal to B. So we start with X belongs to A. This small x we are taking as an element which is there in A, and X is that set in which X is there. So X is subset of power set of A. So X will be set of B also, because we are given PA is equal to PB. So that means X belongs to B. The elements which are there in capital X, they will belong to B. X belongs to A and X belongs to B. So therefore A is subset of B. Let's mark this as equation number 1. Conversely, we can prove by taking y belongs to B. Then this is capital Y. It's a set which contains the elements of this small y. It will be subset of power set of B because PB is equal to PA. So we can write this using the same. The small y belongs to A, y belongs to B, and y belongs to A. Therefore, B is subset of A. This we mark as equation number 2. So from 1 and 2, A is equal to B. That's your result. Is it true that for any sets A and B, PA union PB is equal to PA union B? Justify your answer. No, it's not true. To give an example, let us take A is equal to suppose 1, 2 and B is equal to 2, 3. Then as we know, A union B is equal to 1, 2, 3. PA is the power set of this set A, that is 5, 1, 2 and this whole set 1, 2. Similarly, PB will be equal to 5, 2, 3, 2, 3. And power set of A union B is equal to 5, 1, 2, 3, 1, 2, 2, 3, 1, 3 and 1, 2, 3. Now PA union PB. On the left hand side we have PA union PB. So taking union of these power sets will be equal to 5, 1, 2, 3, 1, 2, 2, 3. And you can see it is not equal to PA union B, which is not equal to power set of A union B, or is not equal to RHS. So LHS is not equal to RHS. Eighth question is, show that for any sets A and B, A is equal to A intersection B union A minus B, and A union B minus A is equal to A union B. A is equal to A intersection B union A minus B. Let us take X belongs to A. If X belongs to A, there are two cases. Case 1, either it will belong to A intersection B or it will not belongs to A intersection B. But if it belongs to A intersection B, then it will definitely belong to some set which is added to this. In this case, we are adding only A minus B. X belongs to A and X belongs to A union B, A intersection B union A minus B. So therefore A is subset of A intersection B union A minus B. If X does not belongs to A intersection B, that means X does not belongs to A or X does not belongs to B. This is not possible because X is belonging to A. So if X belongs to A and X does not belongs to B, that means X belongs to A minus B. Have you mentioned? X belongs to A minus B means X belongs to A and X does not belongs to B. Again, if X is there in some set, and if we add any other set to this, it will still belong to that set. So here we have added A intersection B. We started with x belongs to A, and x is also belonging to A minus B union A intersection B. Therefore A is subset of A minus B union A intersection B. That means from both of these cases we got the same result, that is A is subset of A intersection B union A minus B. Now to prove it to be equal, we need to prove that A intersection B union A minus B is subset of A. To prove that, as we know, A intersection B is subset of A. Also A minus B is subset of A. Their union will also be subset of A, because if A is subset of B, if I write here, if A is subset of B and some C is also subset of B, then A union C will also be subset of B. So using that, we have written A intersection B union A minus B is subset of A. So combining these results, both the equations, let us mark this equation number 1 and this as equation number 2. So from 1 and 2, we get A is equal to A intersection B union A minus B. Next part is prove that A union B minus A is equal to A union B. So this is A union B minus A, we can write B intersection A complement using distributive law, that is A union B intersection A union A complement, which is equal to A union B intersection A union A complement is the universal set. Okay, we mention here what we have written here, U is the universal set. A union B intersection universal set is A union B. That is your result, that is right hand side. We started with the left hand side and we proved equal to right hand side. So this is your answer. Ninth question is using properties of sets show that A union A intersection B is equal to A, and second part is A intersection A union B is equal to A. Solving first part, we know is A subset of A, every set is subset of itself, and A intersection B is subset of A. Therefore A union A intersection B will also be subset of A. Again using this method, that is A is subset of B, C is subset of B, then A union C will subset of B. This we can mark as equation number 1. Also A is subset of A union A intersection B. We have added just something to A, so naturally A will be subset of this. Let us mark equation number 2. So from 1 and 2, we get A is equal to A union A intersection B, which is your first part. Second is A intersection A union B is equal to A. So let us take left hand side. This is A intersection A union B. Using distributive law, A intersection A union A intersection B. A intersection A is A union A intersection B, which is equal to A, because we have proved this in first part from part 1. So that's your answer. 10th question, show that A intersection B is equal to A intersection C need not imply B is equal to C. To say no, let us take an example. Let A be a set that is 1, 2. B is something 2, 3. And because A intersection B should be equal to A intersection C, so let us take C is equal to 2, 4. So you can see what is A intersection B here, 2, and A intersection C is also 2, but B is not equal to C. Eleventh question is, let A and B be sets. If A intersection X equal to B intersection X equal to phi and A union X equal to B union X for some set X, show that A is equal to B. Let us take A union X is equal to B union X. Let us take intersection of A on both sides. Using distributive law, this is A intersection A union A intersection X is equal to A intersection B union A intersection X. A intersection A is A union A intersection X is phi. This is A intersection B union A intersection X is phi. We mention over here A intersection X is phi. A union phi is A, and A intersection B union phi is A intersection B. Let us mark this equation number 1. Now as we took intersection with A, let us take intersection with B. B intersection A union X is equal to B intersection B union X. Using distributive law, B intersection A union B intersection X is equal to B intersection B union B intersection X. Directly you could write B over here, no problem. So this is B intersection A union B intersection X is phi. B intersection B is B union, this is phi. Using B intersection X equal to phi. This is B intersection A. This is B union phi is B. Let us mark this equation number 2. So from 1 and 2, we get A is equal to B. That's your result. 12th question is, find sets ABC such that A intersection B, B intersection C and A intersection C are non-empty sets and A intersection B intersection C is equal to phi. So let us solve this by using example. Let A is equal to 1, 2, B is equal to 2, 3 such that A intersection B is non-empty set, and C let us take as 3, 1 because A intersection should also be a non-empty set. So A intersection B is 2, B intersection C is equal to 3, A intersection C is equal to 1. But we don't have anything common in A, B, C. So A intersection B intersection C is equal to phi. That's your answer. 13th question is, in a survey of 600 students in a school, 150 students were found to be taking tea and 225 taking coffee. 100 were taking both tea and coffee. Find how many students were taking neither tea nor coffee. So there are two methods, either by using formula or by using Venn diagrams. You can solve these type of sums. Using Venn diagram, just draw the universal set, and then in that as many sets are there, draw it. Like suppose this is the set of the students who like tea and others who take coffee. Start with the common one, both tea and coffee. Okay, 100 are there which take tea and coffee both. 150 are there who take tea only, so 100 are already here, so 50 will be taking only tea. 225 taking coffee, so 125 this side. Okay, in a survey there were total 600 students, so totally we got here 150 and 275. 600 minus 275, 325. So 325 students are there, those who are taking neither tea nor coffee. So this is one method which we have used here, that is Venn diagram. Otherwise you can use it like number of students total are 600, number of students like coffee are 150, sorry tea, and number of students like coffee are 225, and those who like both, they are 100. So we know how to find this. We need to find which are not taking coffee and not taking tea. Okay, not taking tea and not taking coffee. This we can write as T union C complement, which in turn we can write total, that is the number of elements that is in the universal set, minus T union C. So this is 600. T union C, we know formula, that is NT plus NC minus number of elements who are taking, or the students who are taking tea and coffee both. So this is 600 minus 150 plus 225 minus 100. So checking this, what we are getting, this is 5275. So this is 325. So anyhow you can solve this sum either by using formula or by using Venn diagram. 14th question is, in a group of students, 100 students know Hindi, 50 know English and 25 know both. Each of the students knows either Hindi or English. How many students are there in the group? So using Venn diagram, this is your universal set, and in that we make sets like those who know Hindi and those who know English. We start with the common region. 25 know both. Okay, 25. Those who know Hindi, 100. 25 already there, so 75 know only Hindi. 50 know English, so 25 already there, 25 is already there in the common, and 25 know only English. Okay, so as it is given that either they know Hindi or English, that means no element is there, no student is there who don't know Hindi or English. So we are asked how many students are there in the group. So total we have 125 students. So total students 125. I hope it is clear. You can solve by using formula also. That is 100 students know Hindi, that is NH we can write, and number of students knowing English 50, and number of students knowing Hindi and English 25, and we need to find the total, that is N of H union E, because there is no student in this region. So NH plus NE minus NH intersection E. So this is 100 plus 50 minus 25, that is 125. 15th question is, in a survey of 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, 26 read newspaper I, 9 read both H and I, 11 read both H and T, 8 read both T and I, 3 read all 3 newspapers. Find the number of people who read at least one of the newspapers. Second is the number of people who read exactly one newspaper. So this will solve using Venn diagram. You can use formula also. So this is your universal set. Here we have 3 types of sets. So we'll draw 3 sets, that is in the form of 3 circles. This is your newspaper H. This is for newspaper T. This is for newspaper I. We'll start with the common reason. 3 read all 3 newspapers. So this is the common reason, 3. Then we start with the 2 regions. 8 read both T and I. So common to T and I is this reason. 3 is already there. Total 8. So we have to write 5 here so that it becomes 8. Then 11 read H and T. Okay, H and T, this reason should be 11. 3 already there, so it should be 8 over here. 9 read both H and I. Okay, 9 should be in this reason. 3 already there, so 6 should be here. Now coming to 1, that is now I. 26 read newspaper I. So I, this circle should have 26 in total. So already we have 6 plus 3, 9 plus 5, 14. So 12 should be reading only I. Then we have 26 read newspaper T. So in this circle total 26 should be there. 8, 3, 11 plus 5, 16 already there. So 10 should be here in this region. And 25 read newspaper H. So this should be 25. So 11 plus 6, 17 there, so 25 minus 17, 8 should be here, and total 60 people are there. So let us count all these. So this is 25 plus 5, 30, 40, 52. So 8 are there, those who don't read any of the newspapers. Now let's answer what is asked. The number of people who read at least one of the newspapers. So you can see all the people, those who are in these circles, they read at least one newspaper. Only these 8 are there, those who are not reading any newspaper. So if we count these, this is 25 plus 5, 30, 40, 52. So 52 people are there who are reading at least one newspaper. Second is the number of people who read exactly one newspaper. So these 8, 10 and 12, these are reading at exactly one newspaper. That is 12 plus 8, 20 plus 10, 30. So this is your answer. 16th question is, in a survey it was found that 21 people like product A, 26 like product B, 29 like product C. If 14 people like product A and B, 12 people like products C and A, 14 people liked product B and C, and 8 liked all the 3 products, find how many liked product C only. So again using Venn diagram. Again there are 3 sets, so we'll draw 3 circles. Circles we can name as A, B, C, Okay, we start with the common region. 8 liked all the products. Then we come to the region where 2 are common. 14 people like B and C. Okay, B and C, this is the common reason for B and C. So 14 are there or 8 already there, so 6 I write here. 12 like C and A. So C and A, this is the common. Total 12, 8 already there, 4 I mark over here. 14 people like A and B. Okay, so 6 I write here. 29 liked product C. So in this circle total 29 should be there. So 4 plus 8, 12 plus 6, 18 are already there. So 11 we need here. Then 26 liked product B. So 6, 12, 8, 20 is already there. So I write 6 over here. 21 liked product A. This is 12 plus 6, 18 and 3 will be here. Okay, so what is asked? How many liked product C only? Only C. So this is the answer. Liked product C only is equal to 11. That's your answer.